Welcome to the video on using scientific notation. In this video, we'll talk about scientific notation and how we use it in applications. The first part of the video, we'll talk about just using multiplying and dividing. This would be 10, 100, 1000, whatever, but mainly I'll stick with just 10 because they all work the same way. Then we will go into what is the format for scientific notation, and there's a couple of different ways that it can be shown. Then we'll go into how to apply scientific notation in doing multiplication and dividing. And then finally, in a conclusion, you may be wondering, why, if I've got a calculator or I have a phone that has a calculator on it, why do I even need to know how to do any of this? I can just have my phone do it for me. And so I'll give you some thoughts about that, and particularly if you're someone that's not in an engineer or not in a scientific field, but occasionally you do have to work with these numbers, or sometimes it's even advantageous to use scientific notation as an easy way to make calculations. Okay, this is multiply by 10, and let's start with, I have 152 times 10. If we use long division, we start out with the 0, and of course 0 times 2 is 0, 0 times 5 is 0, and 0 times 1 is 0. And I'm being a little extra laborious in how I do this, just to not to make any assumptions about what I'm doing or why I'm doing it. So next we go over to the next column, which is 1. And so that means that we're going to multiply 1 times 2, but we skip this column here. We go over to the next column. So that's going to be 2. And then 1 times 5 is 5, and 1 times 1 is 1. Now, when we add all of these up, we get 0, 2, 5, and 1. If I rearrange this slightly, I could say I have 152.0 times 10, and I can have my 10 to the first power. It does not change anything. I've just rearranged everything a little bit. And of course that we know from the long division that this is 1, 5, 2, 0. So what has happened when I multiply by 10 is I took my decimal place that was here, and I moved it one place to the right. And that's kind of shown by this right here. So if I go down here, and we do the same thing, only this time I have a decimal point. We have 0 times 0.6. Well, that's just 0 times 6 is 0. 0 times 8 is 0. 0 times 1. And then we have 1 times 6, 1 times 8, 1 times 1. All right, when we add this up, we have 0, 6, 8, 1, and there was one decimal place, so we have to keep that there also. So again, if I do like I did above, and if we rewrite this, we have 8.6 times 10 to the 1. That gives us 18,186.0. And we can see that what we did is we took the decimal place that was at 18.6 and moved it one place to the right. So here that gives us 18,186.0. And up here that gave us 150.20. Put my comma in there. That gives us 1,520. So whenever we multiply by 10, the only thing that is occurring is that we're moving the decimal place one place to the right. Divide by 10. Here I have two examples. 152.0 divided by 10, and then we have 18.6 divided by 10. And here I'm going to do long division. So first of all, 10 goes into 15 one time. So I can put my 1 here. 1 times 0 is 0. 1 times 1 is that. So I come across here, and that gives me my 5, and then 2. And 10 goes into 52 5 times. So that would be 50, which gives me 2, and I bring down my 0. There's a decimal point here, so I would need to put my decimal point there. And 10 goes into 20 2 times. So if I take 152 divide by 10, I get 15.2. As I did with my multiplication, if I rewrite this a little bit and say 1, 5, 2.0 divided by 10 to the first power, that equals to 15.2. The result of dividing 2 changes my decimal point one place to the left. And so if we go down here, we have 18.6. Let's see, my decimal point would be right there. So 10 times 18 is going to be 1. And then that gives me my 10. And that is 8. And then bring down the 6. So that's going to be 8. 8 times 10 is 80. Bring down the 6. I'll add a 0. So 10 times 60 is 6. And so that is 60. And that gives me 0, which means there's no remainder. So if I did the same thing here and said 18.6 divided by 10 to the first power is going to equal to 1.86. And here again, the decimal point moved one place to the left. So when we divide, we are going to move decimal to the left. Now, I could do something similar by saying 18.6 divided by 10, and the answer is still the result. All of this is just different ways of showing dividing, so the result still would come out to be 1.86. Now that we have gone through how to multiply and divide by 10, let's do a little bit of a review and recap what we have learned. And hopefully at this point you should be able to do these calculations in your head. We have 256 times 10, and that would simply mean that we take our 256.0, multiplying it by 10 means that we're going to move the decimal point one place to the right. So that's going to give us 2560. Okay, here we take our 16.1 divided by 10, which would be the same as, again, if I rewrite it, 16.1 divided by 10 means that we're going to move this decimal point one place to the left. So that's going to give us 1.61. All right, now here I've changed it so that we've got 8.5 times 100. We can look at this a couple of ways. One is we got 8.25 times 10 to the 2, because 10 times 10 is equal to 100. And that's going to simply mean that we take this decimal place and we're going to move it 2 places to the right. So that gives us 825. Here I have 7.5 divided by 100. And so that would be the same thing as 7.5 divided by 10 to the 2. Of course, when we divide, we're going to move the decimal place 2 places to the left. That's 1, and that's 2. So that means that we would have to add a 0 onto the end. So we would have 0, 7, 5. So there's your 7.5 divided by 100. Start there, and we go 2 to the left. Down here, I have 0.002 times 1,000, which is the same thing as 10 to the 3. So that means that we're going to take this decimal point and move it 3 places, 1, 2, 3, to the right. So that would give us 2.0. And that concludes the recap. There are 2 parts to scientific notation. If you look at this example right here, you have the numbers part, and then you have the 10 to the exponent part. And a second way that you can show this is to use the numbers part, and then this e takes the place of the 10, and there's the exponent. So when we look at the individual values, you can see here that the first whole number that it's to the left of the decimal, and it will be between 1 and 9. Then if we look beyond that to the 0.42, there can be one or more values that's to the right of this decimal. And that is really dependent upon the precision that you want in your calculation. And also, if you're using this in a computer, actually the precision of your computer and how many decimal places that it can manage. The final part to this is the exponent, and that number can be a positive value or a negative value. Now, keep in mind that when you are working with this, and again, let's go down here, I'm going to say 1.42 times 10 to the 2, that these two work together. If for some reason I wanted to do a math calculation and it was more advantageous to say 14.2 times 10, well, what would this value here be? It would be 1. Because that says if it's times 2, we're going to move the decimal places 2 places to the right, which would be 142. This says we're going to move it 1 place to the right, which again would be 142. Now, this is not strictly scientific notation, but if you're working with a calculation and it makes more sense to use it this way, or it makes it easier to do the calculation, you can do that. Just the same as if we want to get rid of the scientific notation altogether, we could simply represent this as 1, 4, 2. Now, let's go over here, and let's say that we have 156 times 10. Well, let's make that 1.56 times 10 to the minus 2. That means that, again, this is in scientific notation, but if we wanted to change it, we could do something like 15.6 times 10 to the minus 3, because if I look here and I move the decimal point 2 places, it's going to give me 0.0156. Here, if I'm going to move that 3 decimal places, it's going to give me 0.0156. And of course, if we wanted to just work without the scientific notation, if that would be more advantageous, again, we could just change this again, take to 0.0156. So when you're doing calculations and using this methodology, then keep in mind that you keep track of the decimal place by the values that you have over here. And so if it's more advantageous to do it this way, do it this way. If it's more advantageous to do it this way, then use that. But this is just another way of helping you whenever you're doing calculations. Why use scientific notation? It is used to represent very large or very small values. To give you some examples, if we look at the speed of light in a vacuum, it is generally recognized to be 186,000 miles per second. If we represented that in scientific notation, it would be 1.86 times 10 to the 5 miles per second. Number that you will typically always see in scientific notation is Avogadro's number, which is the number of atoms or the number of molecules that's in a mole. And if you're in chemistry, then this will make sense. Otherwise, just recognize it as just a very large number. And it's typically a 6.022 times 10 to the 23rd power. A consideration when you're using scientific notation is the precision required for your calculation. Usually, I guess, when you're working with computers, you don't think about this so much. It doesn't matter if you go out 20 decimal places or not. But in reality, those decimal places do have an effect on your overall calculation. But as an example here, when we look at Avogadro's number, it can be represented as 6.02 times 10 to the 23rd power, 6.022 times 10 to the 23rd power, or 6.0223 times 10 to the 23rd power. All of this would give you a slightly different number, but if you're going out to the 23rd power, then probably the first few decimal points don't really make a whole lot of difference because of the orders of magnitude that you're working with. Okay, let's start with a example of how to use scientific notation to multiply two numbers. I have 2.04 times 10 to the 5, and that's multiplied by 8.0 times 10 to the 4. Also, I am using the asterisks here to represent multiplication. And if you are not familiar with that terminology or usage, in most programming languages, the asterisk is used to represent multiply so that it's not confused with the letter X. I will kind of use these interchangeably since all of this is being done by hand. But first thing that we would want to do is to rearrange so that we have variables in a more easily way to perform the operations on them. So I'm going to start by taking 2.04, and that is going to be multiplied by 8.0. So we've taken our variable parts or our value parts and put those together, and then I have 10 to the 5 times 10 to the 4. Okay, the reason I do this is that with exponents, whenever we are multiplying two values that have exponents, like 10 to the 5 and 10 to the 4, then the exponents are simply added. So that would become 10 to the 5 plus 4. And so the final result there is just simply 10 to the 9. here. We would just multiply these out the way that we normally would. And since for these videos, I am going calculator free, which means I do things the old-fashioned way. I'm going to take 2.04 and I'm going to multiply it times 8.0. And times 4 is 0. And then, of course, that would be 0 all the way across. So we'll just use a shortcut. And so now 8 times 4 is 16. Excuse me, 8 times 4 is 32. So I put my 2 here. And we would carry the 1. We would carry, I'm still thinking 16. We would carry the 3 because 8 times 4 is 32. Well, 8 times 0 is 0. So 3 plus 0 is going to be 3. And then 8 times 2 is 16. And now our decimal place, we're going to go over 1, 2, 3. So there's 1, 2, 3. So our answer over here is going to be 16.32 times 10 to the 9th power. Now, if we want to put this into proper scientific notation, we need to move our decimal one place over. So we would have 1.632 times 10, and that would be 9, plus we're going to move our decimal one place to the left, so that would be a +1 there. So our final answer is 1.632 times 10 to the 10. And here is our final result. Here is a second example of using scientific notation and multiplying two values together. First value is 1.29 times 10 to the 3, and that's going to be multiplied by 2.0 times 10 to the -3. So this is a little different in that before we were using all positive numbers in our exponents. This time I have a negative number. But we're going to start the same way, which is that we want to rearrange so that we will put the number part 1.29 times 2.0 together, and then we'll put the exponent part. So we have 10, and remember before we said that if it's multiply, we're going to add the exponents. So we have 3 plus a -3. All right. So if we have plus basically times a minus, that's going to give us a minus. So we have 10 to the 3 minus 3, which gives us 10 to the 0. And as we talked earlier, any times that we have any value here that has an x other than 0, that has an exponent of 0, then that means that the result is 1. So that's on the exponent side. Now, once again, being calculator free and yet still trying to show my work, which is a part of the reason for doing this, is I have 1.29 times 2.0. So once again, that's going to be a 0. 2 times 9 is 18. So there's the 8. I carry the 1. 2 times 2 is 4, plus the 1 is 5. And then 2 times 1 is 2. And I have 1, 2, 3 decimal places. So that's 1, 2, 3. So that means that my decimal places goes there. And I have 2.58 times 1, which is basically 2.58. And that is my result. And there's no need to put that into scientific notation. In another example, we're using scientific notation to divide two numbers. So you can see that I have 4.12 times 10 to the third power, and that is divided by 2.00 times 10 to the fourth power. So first thing that we're going to do, as we did before, is just to rearrange so that I have 4.12 divided by 2. Of course, I could leave the zeros off. And that is times 10 to the 3 divided by 10 to the 4. Now, we can look at the exponents a couple of different ways, but probably the easiest is just to recognize that when we multiplied exponents, we added. When we divide exponents, we're going to subtract. So what that means is that over here, we're going to have 10 to the 3 minus 4, which is going to be 10 to the minus 1. On the other side, for the numbers part, we have 4.12 divided by 2. So 2 goes into 4 2 times. So that's a 0. There's my decimal point. And 2 does not go into 1. So there's my 0. And I bring down my 2. And 2 goes into 12 6 times. So then my ultimate number, a value, is going to be 2.06 times 10 to the minus 1. There's the result. And that's in scientific notation. This is the second example of using scientific notation to divide two values. And in this one, notice that in here that we are going to divide by 10 to the minus 2. So before we used positive exponents. In this example, I have one that is a negative exponent. So as before, we will start by breaking out our exponents from the number part. So I have 5.25 divided by 5. And I don't have to put in the zeros, and I'll make it easier on the dividing, so we'll just leave it like that. And then we have times 10 to the 4 divided by 10 to the minus 2. All right, before the other example, we said that in division, we would subtract exponents. So we have 4 minus, and here we have a minus 2. And whenever we have a minus times a minus, that becomes a plus. So we have 10 to the 4 plus 2, which is going to give us 10 to the 6. And let me erase this little part here. Back to there. Bring my pen back here, and we have 10 to the 6. Now we'll go over here. I have 5.25 divided by 5. 5 goes into 5 one time. So that's a 0. There is our 0. 5 doesn't go into 2, so we bring down the 5, and we put a 0 here. 5 goes into 25 5 times, so there's our 5. So our answer is going to be 1.05 times 10 to the 6. So there's the answer. Or if we wanted to rewrite it, just to clean it up a little bit, 1.05 times 10 to the 6. And there's our result. Conclusions. As we've gone through each of these calculations as far as how to multiply, divide, scientific notation, and typically where we find them, which is to use them for either very large numbers or very small numbers. There's a couple of things that we can use scientific notation calculations for. One is a way to double check calculations. And here I mean more about orders of magnitude. I remember many years ago, I started out my first year of college as an engineering student, learning how to read a slide rule. Then I went in the Army. 4 years later, I went back to school, and slide rules were out and calculators were in. A few years after I had finished up my nuclear engineering degree and was working for a company, I happen to be working with a lot of the old nuclear engineers that had actually built some of the first nuclear reactors and had been involved with the building of the USS Savannah, which was the one and only nuclear powered commercial ship. But one of the questions that I asked some of these engineers was, what difference do you see in the students that's coming out of school now that are trained basically on using computer programs and calculators versus people like yourself that when you came out you had to work with slide rules and hand calculators and all of that? And the big answer was that that students today, because they can just plug a number into a computer program or into their phone and hit a couple of buttons and all the equations are done for them, is that they have no feel for the order of magnitude. And just to give you an example of that is, say someone is doing a shielding calculation to see how much or how much concrete or how thick should concrete be to shield a certain radioactive source so that it's at safe levels for people to be on the other side of the shield. And for a lot of the younger students, they'd put it into the calculator, and if the calculator said 10 feet, then that's what they would use, as they would use 10 feet. Whereas for the older guys, they would, by just using the exponents, be able to at least get an order of magnitude that may say, no, it's not 10 feet. It's the true answer is closer to 2 feet. And then when they get their results from the computer, it may say 2.156 feet. So that is one of the things to keep in mind about particularly order of magnitude. Second reason, of course, is that you may not have a smartphone or calculator available when you need to do some of these calculations, depending upon, the nature of your job and all of that. The other is a need to do a quick estimate, and this is something that I have found is very useful to me. And sometimes I'm taking just regular numbers and converting them to scientific notation because that makes it a lot easier to work with the exponents and get the order of magnitude. And just to give you and sometimes, say, if you're working on your SATs or GREs or things along those lines, or even you're taking the engineer in training exam, there are sections where you have to do math. And of course, those are ABC type answers. And usually a couple of them are going to be ridiculous, and a couple of them are going to be close. And of course, one of them is going to be right. Well, to do a calculation like this could take some time, but if you can look at the answers and see that, well, we could do an estimate and do rounding, and we have 7 divided by 3 times 10 to the 2 minus 3. Well, 3 is going to go into 7 at least twice. I don't have to do a detailed result, and that this is going to be 10 to the minus 1. So that gives me an answer of 0.2. All right, I just did that by a quick estimate and rounding off. Then, just so that you can see, before I started this, I went in and actually used my calculator to calculate out these values, and I came up with the real answer. My fingers aren't working well today, excuse me. The real answer was equal to 2.2 times 10 to the minus 1 which would equal 0.22. And so that is the actual number that comes out, which isn't far from what I estimated. So this concludes working with scientific notation and how to use it in calculations. So thank you very much.